This class we work out 10 problems on AC circuits. Problem number 1. An alternating voltage is given by V is equal to 311 into sine 314t. Calculate number 1 frequency, number 2 period, number 3 maximum value, number 4 average value and number 5 RMS value. We know that V is equal to Vm into sine omega t. Here the omega is equal to 314. Omega is equal to 2 pi f, that is equal to 314. Therefore f is equal to 314 divided by 2 pi, that is equal to 50 Hertz. Frequency is 50 Hertz. Once I know frequency, I can find time. Time t is equal to 1 by f, that is equal to 0.02 seconds. The third question is maximum value. Here the maximum value is 311. The fourth is average value. Average value is equal to 0.637 into Vm. 0.637 into 311, that is equal to 198 volts. And fifth is RMS value. RMS value is equal to 0.707 into Vm. That is equal to 0.707 into 311, that is equal to 219.87. I can find form factor and peak factor. Form factor is equal to RMS value divided by average value. 219.87 divided by 198, that is equal to 1.11. It's a sine wave. Peak or crest factor is equal to maximum value divided by RMS value. That is equal to 311 Vm. Vm is 311 divided by 219.87, that is equal to 1.414. I can also find the peak to peak voltage. This is 311, this is 311. So peak to peak is 2 into Vm, 2 into 311, that is equal to 622 volts. Problem number 2. An alternating current is given by I is equal to 700 into sine 314t. Calculate number 1 frequency, number 2 maximum value, number 3 average value, number 4 RMS value, and number 5 instantaneous value of current when t is equal to 3.5 milliseconds. We know that I is equal to Im into sine omega t. I is equal to 700 into sine 314 into t. Omega is equal to 2 pi f. Here omega is 314. I can find f. F is equal to 314 divided by 2 pi, that is equal to 50 Hertz. I can find time. T is equal to 1 by f. That is equal to 1 by 50 is equal to 0.02 seconds. Next is maximum value. Here the maximum value is 700. Im is equal to 700 amps. The third is average value. Average value is equal to 0.637 into Im. That is equal to 445.9 amps. RMS value is equal to 0.707 into Im. That is equal to 494.9 amps. Now I have to calculate instantaneous value I. That is equal to 700 into sine 314 into 3.5 into 10 power minus 3 because t is given. Here omega t is equal to 314 into 3.5 into 10 power minus 3, which is in radians. So I have to convert into degrees. 314 into 3.5 into 10 power minus 3 into 180 by pi degrees. Theta is equal to 62.97 degrees. Sine 62.97 is equal to 0.890. Therefore, instantaneous value is equal to 700 into 0.890, that is equal to 623 amps. Instantaneous value of current when t is equal to 3.5 milliseconds is 623 amps. Problem number 3. The alternating current is given by I is equal to 14.14 into sine 314t. Find A, the RMS value, B, instantaneous value when t is equal to 3 milliseconds, C, the frequency, and D, the time taken to reach 10 amps for the first time after passing through zero value. That's the question. We know that I is equal to Im into sine omega t, which is given 14.14 into sine 314t. First we have to find the RMS value. IRMS is equal to 0.707 into Im, that is equal to 10 amps. IRMS is equal to 10. We can also find I average. I average is equal to 0.637 into Im, that is equal to 9 amps. In AC circuit, RMS value is always greater than the average value. The next is 2 pi ft, that is equal to 314 into 3 into 10 power minus 3. That is the instantaneous value when t is equal to 3 milliseconds. Here 3 milliseconds is given. I can find 314 into 3 into 10 power minus 3, that is equal to 0.942 radians. I have to convert it to degrees. Theta is equal to 0.942 into 180 by pi, that is equal to 53.97 degrees. I can find sin theta. Sin 53.97, that is equal to 0.809. The instantaneous value I is equal to Im into sin theta, that is equal to 14.14 into 0.809 is equal to 11.44 when t is equal to 3 milliseconds. Next is I have to find the frequency. Omega is equal to 314, therefore f is equal to 314 by 2 pi, that is equal to 50 Hz. I can find the time. Time t is equal to 1 by f. 1 by 50 is equal to 0.02 seconds. The last question is the time taken to reach 10 amps for the first time after passing through zero value. Instantaneous value is 10. Therefore 10 is equal to 14.14 into sin 314t. Therefore 10 by 14.14 is equal to 3 sin into 314t. Here 10 by 14.14, that is equal to 0.707. 0.707 is equal to sin 45. Sin 45 is equal to 0.707. So instead of 0.707, I can write sin pi by 4. That is equal to sin 2 pi into 50 into t. So 2 pi f. Here f is 50. That into sin into pi by 4, that is equal to sin 2 pi into 50 into t. I can find t. T is equal to 0.0025 seconds or 2.5 milliseconds. Here this is the graph. This is 20 milliseconds. This is 10 milliseconds. Here this is 5 milliseconds. We will get a maximum at 14.14 in 5 milliseconds. 2.5 milliseconds we will get a 10 amps current. We can also check 5 milliamps is equal to 314 into 5 into 10 power minus 3, that is equal to 1.57 radians. Again I convert into radians into degrees into 180 by pi, that is theta is equal to 89.95. Sin 89.95 almost 1. Therefore I simply substitute. I will get I is equal to 14.14 into 1, that is equal to 14.14. I will get the maximum at 5 milliseconds. Problem number 4. An alternating current of frequency 50 Hz has a maximum value of 120 amps. The question is, write down the equation for the instantaneous value. Number 2, time taken to reach 96 amps for the first time. Here the maximum value is given 120. We can find I.R.M.S. I.R.M.S is equal to 0.707 into 120, that is equal to 84.84 amps. I average is equal to 0.637 into 120, that is equal to 76.44 amps. Now we can write the equation for the instantaneous value. We know that I is equal to Im into sin omega t. Im is given 120. Sin omega t, omega is equal to 2 pi f. F is given 50. So I can write the equation, that is equal to 120 into sin into 100 into pi into t. That's the equation. Number 2, time taken to reach 96 amps for the first time. Here the instantaneous current is given. I is equal to 96. 96 is equal to 120 into sin 100 into pi into t. So 96 by 120 is equal to sin 100 into pi into t. So 96 by 120 is equal to 0.8, that is equal to sin 100 into pi into t. Sin inverse of 0.8 is equal to 56.13 degrees. Therefore 53.13 into pi divided by 180, that is equal to 0.927 radians. I can find the time. T is equal to 0.927 divided by 100 into pi, that is equal to 2.95 milliseconds. So time taken to reach 96 amps for the first time, the time is 2.95 milliseconds. Here this is the graph. This is 120, maximum value is 120. Here frequency is given 50. Therefore, time t is equal to 1 by f, that is 0.02 seconds or 20 milliseconds. Here this is 20 milliseconds, this is 10 milliseconds, this is 5 milliseconds. At 5 milliseconds we get a maximum current, that is 120 amps. So this is 2.95 milliseconds. Problem number 5. An alternating current is given by 10 into sine 314 into t. Determine the time taken from t is equal to 0 for the current to reach a value plus 6 amps for the first and second time. That's the question. We know that instantaneous current I is equal to Im into sine omega t. Here instantaneous value is given 6 and Im is given 10. 10 into sine 314 into t. 6 is equal to 10 into sine 314 into t. We know that omega is equal to 2 pi f. We can find f. F is equal to 314 divided by 2 pi, that is equal to 50 Hz. We can find time. Time t is equal to 1 by f, that is equal to 0.02 seconds or 20 milliseconds. Now we have to equate 6 is equal to 10 into sine 314 into t. 6 by 10, that is equal to sine 314 into t. 6 by 10 is equal to 0.6, that is equal to sine 314 into t. We have to find sine inverse of 0.6, that is equal to 36.86 degrees. We have to convert it into radians. 36.86 into pi by 180, that is equal to 0.643 radians. We can easily find the time. T is equal to 0.643 divided by 314, that is equal to 2 milliseconds. So time taken to reach plus 6 amps, that is equal to 2 milliseconds. The question is for the first and the second time. First time is over, that is 2 milliseconds. For the second time, time taken to reach is 20. The total cycle is 20. 20 plus 2, that is equal to 22 milliseconds. For the first time is 2 milliseconds. Second time 22 milliseconds. Problem number 6. A sinusoidal alternating current has a maximum value of 20 amps. Find the instantaneous value at A 1 by 12 cycle, B 1 by 6 cycle, C 1 by 2 cycle, D 5 by 8 cycle and E 3 by 4 cycle. We have to find the instantaneous value. I is equal to Im into sine omega t. Im value is given 20 amps. I can write I is equal to 20 into sine theta. For one cycle is equal to 360 degrees. At 1 by 12 cycle, theta is equal to 360 by 12, that is equal to 30 degrees. Therefore, instantaneous current is equal to 20 into sine 30, that is equal to 10 amps. At 1 by 6 cycle, theta is equal to 360 by 6, that is equal to 60 degree. The instantaneous current I is equal to 20 into sine 60, that is equal to 17.32 amps. At 1 by 2 cycle, theta is equal to 360 by 2, that is equal to 180 degrees. Instantaneous current I is equal to 20 into sine 180. Sine 180 is 0, therefore instantaneous current is 0. At 5 by 8 cycle, theta is equal to 360 into 5 by 8, that is equal to 225 degrees. The instantaneous current I is equal to 20 into sine 225, that is equal to minus 14.14 amps. At 3 by 4 cycle, theta is equal to 270 degrees. Instantaneous current I is equal to 20 into sine 270, that is equal to minus 20 amps. Problem number 7. An alternating voltage has an RMS value of 230 volts. Find A. Instantaneous value 0.0125 seconds after passing through maximum positive value, and B. The time measured from a positive maximum value when the instantaneous voltage is 162.63 volts, frequency is equal to 50 Hz. That's the question. Here the 230 volt is a RMS voltage. So Vrms is equal to Vm by root 2. I can find Vm. Vm is equal to Vrms into root 2. That is equal to 230 into root 2. That is equal to 325.27 volts. The maximum voltage is 325.27 volts. Frequency is given 50 Hz. Time t is equal to 1 by f. 1 by 50 is equal to 0.02 second. That is equal to 20 milliseconds. This is 20 milliseconds. This is 10 seconds. Half cycle is 10 seconds. So time to reach maximum value is equal to t by 4. That is equal to 20 by 4 is equal to 5 milliseconds. To reach 325.27 volts is equal to 5 milliseconds. Time required from the beginning of the cycle to a point corresponding to 12.5 after passing through positive maximum is equal to 5 plus 12.5, that is equal to 17.5 milliseconds. That is equal to 0.0175 seconds. So this is in radians. 2 pi ft is in radians. I have to convert into degrees. 2 pi into 50 into 0.0175 into 180 by pi, that is equal to 315 degrees. Once I know the degrees, I can find the instantaneous value. I is equal to 325.27 into sine 315, that is equal to minus 230 volts. This is minus 230 volts. The next question is the time measured from a positive maximum value when the instantaneous value is 162.63. I is equal to 162.63. Therefore, 162.63 is equal to 325.27 sine 314 t. 162.63 by 325.27, that is equal to sine 100 into pi into t. 162.63 divided by 325.27 is equal to 0.5. 0.5 is equal to sine pi by 6, that is equal to sine 30. Instead of writing 0.5, I can write sine pi by 6. Sine pi by 6 is equal to sine 100 into pi into t. I can find t. 1 by 6 is equal to 100 into t. T is equal to 1 by 600. That is equal to 1.67 into 10 power minus 3 or 1.67 milliseconds. Here 1.67 milliseconds. Here positive maximum, the time measured from a positive maximum value when the instantaneous value. This is positive maximum value. Here this is 1.67. 5 minus 1.67, that is equal to 3.33. This distance is 3.33. Problem number 8. An alternating current when passed through a resistor immersed in a water for 5 minutes just rise the temperature of water to boiling point. When direct current 5 amps was passed through the same resistor under identical condition, it took 10 minutes to boil the water. Find the RMS value of alternating current. IDs is given 5 amps. Resistor is equal to R ohms. Heat produced by the alternating current is equal to IRMS square into R into T. That is equal to IRMS square into R into 5 into 60. This is 5 minutes is given 5 into 60 in joules. Heat produced by the direct current I square R into T. I square 5 is given 5 square into R into 10 minutes 10 into 60, that is equal to 15,000 into R into joules. Heat produced by the alternating current is equal to heat produced by the direct current. Equate it, you will get IRMS is equal to 7.07 amps. Problem number 9. The equation for an AC is I is equal to 20 into sine 314 t. Find A maximum value. B. What is the rate at which it is changing in A? C. The value of current after 1 by 250 seconds. That is the question. I maximum is equal to 20 amps when 314 t is equal to 90 degree. That is theta is equal to 90 degree. Sine 90 is equal to 1. B. What is the rate at which it is changing in A? So this condition theta is equal to 90 degree. Therefore sine 90 is equal to 1. We will get a maximum of 20 amps. So di by dt is equal to I is given 20 into sine 314 to differentiate it 20 into 314 into cos 314 t. Here 314 t is equal to 90 degree, cos 90 is equal to 0. The rate at which it is changing in A is equal to 0. The value of current after 1 by 250 second. I is equal to 20 into sine 314 into t is given 1 by 250 in radians. Convert into degrees into 180 by pi. The angle is 71.96. Sine 71.96 is equal to 0.951. Therefore, I is equal to 19.02 amps. The value of current after 1 by 250 second is 19.02 amps. Problem number 10. An alternating current 20 amps. Frequency 50 Hz. The question is A. Write down the equation for instantaneous value and find this value at B 0.002 seconds and at C 0.0120 seconds after passing through the maximum value. The instantaneous value I is equal to Im into sin omega t, that is equal to Im into sin 314 t, that is equal to Im into sin theta. Here the given value is I.R.M.S. I.R.M.S is equal to 20. I can find I maximum. So 20 into root 2, that is equal to 28.28 amps. I can write instantaneous current I is equal to 28.28 into sin 314 t. Next is I is equal to 28.28 into sin omega t. Here t is given 0.002 seconds. Therefore, omega t is equal to 314 into 0.002 seconds, that is equal to 0.628 radians. I have to convert it to degrees. 0.628 into 180 by pi, that is equal to 36 degrees. Therefore, I is equal to 28.28 into sin 36, that is equal to 16.62 amps. The next is 0.0120 seconds. T is equal to 0.0120. Therefore, omega t is equal to 314 into 0.0120, that is equal to 3.768 radians. So, I have to convert into degrees. 3.768 into 180 by pi, that is equal to 215.89 degrees. I is equal to 28.28 into sin 215.89, that is equal to minus 16.58 amps. With this, I conclude my lecture. Thanks for listening.